In this video, we're going to talk about igneous rocks. So igneous rocks are part of the rock cycle. So igneous rocks are going to form by the cooling of molten rock. So this material is known as magma when it's underground, or if it's erupted at the surface, it's known as lava. The difference between the two really is inconsequential though, so you can use the term pretty much interchangeably. I tend to prefer to use the term magma just to make sure we are all on the same page. Alright, so we usually start with igneous rocks when we talk about rocks because the Earth started out with just igneous rocks. It started out as a big blob of molten material after the moon-forming collision, and as it starts to cool down, the first things you're going to form are igneous rocks. So if we're talking about magma or lava, there's really three things that are in it. So it's made up of three different things. The first is the liquid. This is the obvious part. So this is the melted material. So it's when you have minerals that have been heated up so much that the little bonds between the atoms break and those atoms are able to flow around each other, which is why it's a liquid. So this is composed of ions, and those ions are looking for a home to bond back with. The second thing that is in it are solids. So even though it's melted, there's still some solids in there, and you can see in the picture here, things are starting to crystallize just a little bit because that surface is darkening. So this is made up of mineral crystals that are forming as the magma cools. The last thing that's in it is gas. There's lots of dissolved gases that are in the magma, but those are not going to go into the crystal structures as it cools. So they actually have to go elsewhere. And when we look at metamorphic rocks, we're going to see one of the things they do as they go looking for a new home. Now the key to this is that the magma is going to have more and more solid and less liquid as it cools. But the magma itself is going to become more and more enriched in those volatiles since they're not going into the crystal structure. Alright, there's two big categories of igneous rocks that are formed. The first is called extrusive or volcanic rocks. These are going to form at the surface. That means they're going to cool really quickly because it's relatively cold here at the surface. And since they cool so quick, they don't have time to form a whole lot of bonds, and so you end up getting really small crystals. And by small, I mean you can't see them. So they're small enough that you can't see them with the naked eye, but you can see them under a microscope. So where these get their names, extrusive, X means from, so it's coming out of something, kind of like an extruder if you've ever had to use an extruder, or the word volcanic. The volcanoes are actually named after this dude here. This is Vulcan. He is the god of fire, and he lived under a mountain, and he'd go beating on his forge and making his sword, and as he did, it would send sparks up, and the sparks would come out of the mountain, and you'd get volcano eruption. The volcano he actually lived under was one in Italy called Vulcano. So that's where we actually get the term volcano from, is that particular one. The picture on the right, I believe, is an eruption in Mexico of the Cindercone Paracutin back in the 40s. So to be able to see volcanic rocks, you got to go to a volcano. Now we're going to talk about all the different types of volcanic rocks and types of volcanoes that are formed as we get a little bit further into the semester. So I'm not going to focus on it too much here other than to show you some examples of different types of volcanoes. Alright, so since we have extrusive igneous rocks, we also have intrusive. So intrusive rocks are going to form deep below the surface. Since they form deep below the surface and it's nice and warm down there, they're going to cool slowly, and this gives it plenty of time to build nice large crystals. Alright, so these are also known as plutonic rocks, and these are named after this lovely gentleman here. This is Pluto. He's the god of the underworld, also known as the devil, Satan, or Hades, depending on what culture you're looking at. Right there with him is his three-headed dog, Cerberus. So since he's the god of the underworld, that should help you remember where these plutonic rocks form. So when we find plutonic rocks, we actually find them in these igneous intrusions. So igneous intrusions are rock bodies that form when magma cools underground. Right? So In the picture, you have molten material down at the very bottom of the crust, right at that core mantle boundary. And because this material is hotter than the material around it, it starts to rise. It's the same reason why hot air balloons rise. It's the same reason why lava lamps work, is because hot material rises. So these blobs moving up, these teardrop-shaped blobs we call diapirs. Now, if they make it all the way to the surface, they're going to erupt as a volcano, but they don't often actually make it all the way up there. They cool down enough, and then they stall out, and then they just cool under the surface. And these are going to be our plutons. Now, these come in a few different varieties, which are worthy of noting, the largest of which is called a batholith. All right, so batholiths are very large. They're usually composed of either granite or diorite. Right, they cover huge regions. So if you look in the picture here, in California, sort of central California, this is the Sierra Nevada batholith. This is where Yosemite National Park is. That is all one huge chunk of granite. If you ever make the drive out to San Diego, if you take the 8 out, you're actually driving through these Southern California batholiths on your way there. Lots and lots of beautiful, really light-colored white granites through there. All right, so these are huge regional things. And to give you sort of an idea where that term comes from, bath means depth, or something that's really deep. And lith means rock. So this is rock that was really deep, which is kind of cool, right? Now, there's other ones too that are a little bit smaller. One of the smaller pieces is called a stalk. Now, a stalk is just a little bit that's sticking up. It's not as big as a batholith, but it's likely just kind of part of a larger batholith. It's just a little bit that's exposed. Here you go. Here's a beautiful shot of some of those granites in Yosemite National Park. This is Half Dome. When we talk about weathering, we'll talk about why this is a dome. But you see those beautiful white granites through that entire region are quite lovely. All right, some other ones that you're probably going to see. In this case, you have dikes and sills. We've already talked about these before, but just as a little reminder, a dike is going to cut across all your layers of rock. A sill ends up coming up and filling in between the two layers. And so whenever we draw it, it tends to be like a linear feature, right? Either cutting across or with those layers. But it's actually a three-dimensional object, which is something sort of important to keep in mind there. So if we take away all those rocks left behind, you can see that sill is actually a big sheet that's laying horizontal. And a dike is a sheet that's standing kind of vertically, which is kind of interesting to think about it. Here are some examples. Now, these are often basalt, but not always. So in the pictures on the bottom right, that's a basalt dike cutting through. Over on the left, this is actually a picture from Antarctica, and you have dikes of all sorts of different compositions. So the oldest here is these dark basalt dikes. Then a little bit younger, these super white felsic dikes. These probably are granites, maybe a rock called an apatite, which is pretty much all light-colored minerals. And then what looks to be kind of an intermediate diorite or andesite dike cutting through all of those. Here's an example of a basalt sill. So it's going to squeeze in between the layers, so these tend to be pretty fluid. Now sometimes it's not so fluid. If you have thicker, more viscous magma and it squeezes in, what happens is it actually pushes the rocks up and out of the way so to fill in. So this is called a laccolith. So that's your last kind of example there. But you can see kind of the relationship between the magma chambers and the dikes and the sills and the laccolith here. All right, so there's a quick little intro to how we find igneous rocks. In the next video, we're going to look at how to name them.